Hello, I'm Bindita. We present personalized face modeling for improved face reconstruction and motion retargeting. Face modeling is important for applications like face recognition and codec avatars. However, existing face modeling methods are either not sufficient for reconstruction and retargeting or come with significant overhead. Given an arbitrary image as input, our framework separately generates a personalized face model of the user and corresponding facial motion parameters, which can then be combined together to reconstruct the 3D face. However, we can also create a personalized model of another user and retarget the predicted facial motion to that user. We can even use an external 3D character model and retarget the predicted motion to that character. In terms of related works, existing learning-based approaches either use predefined facial models learned from a limited number of 3D scans or train a neural network to represent a face model, but they fail to fully personalize their face models. We argue that expression-specific skin deformations and reflectance variations vary from person to person. While optimization-based approaches have shown improved results with personalizing the face models, such approaches are comparatively slow and do not generalize well to in-the-wild images. For skin texture, existing methods either use a single albedo map per user learned from a parametric texture model or hallucinate expression-specific albedo maps based on general user expression dynamics, thereby failing to capture user-specific high-frequency texture details. For our face modeling, we take multiple frames from a user video as input, learn a common feature from them using shared encoders, which is then decoded into shape and albedo corrections in the UV space. Then, we multiply these corrections with pre-computed attention mask in order to limit the corrections to local regions. We then add the 3D prior to the corrections to get the final personalized blend shapes and dynamic albedo maps for the user. On a parallel branch, we estimate the per frame facial motion parameters such as blend shape coefficients, pose, and illumination. These are then combined to reconstruct the 3D faces, which are then rendered for end-to-end self-supervised training. We show that compared to using only 3D prior, adding only one correction for the neutral blend shape already improves the face shape and texture. Adding correction for each of the expression blend shapes further improves the results. Our 3D reconstructed face is consistent from multiple viewpoints and can also be relighted. As novel training constraints, we add the face parsing loss, which disentangles the geometry from the albedo and provides stronger supervision compared to 2D landmarks. We also add the blend shape gradient loss, which ensures that the gradient between neutral and expression blend shapes remain more or less unchanged after adding the shape corrections, which thereby retains the semantic meaning of the blend shapes. Our personalized modeling accurately captures the user-specific variations in expression blend shapes and captures the high-frequency details like folds and wrinkles in skin texture. Our loss functions also contribute to learning the face model accurately. We obtain better reconstruction results compared to state-of-the-art methods, both quantitatively and qualitatively. In terms of face tracking, we obtain lower landmark error for images and higher AUC value for videos compared to existing methods. In terms of retargeting, our pose and expression estimation is also more accurate. Finally, we show some results for static images under various conditions such as age, head pose, lighting, expressions, occlusion, blur, and facial hair. We also show our frame-by-frame reconstruction and retargeting performance on videos. Note that we accurately disentangle the user-specific face shape and albedo and user-independent per-frame facial motion parameters. while the user performs a range of in the wild expressions. Thank you for listening.